For a numerical example, we have one from Rizzoni's Fundamentals of Electrical Engineering. This is example 7.8 from page 297. And in this problem, we are given a series resistive inductance circuit connected to a AC voltage source, and we're tasked with finding a compensating circuit. So here's our circuit. On the lower left, we have a resistor. It's a 50 ohm resistor, and we have inductance with impedance of 86.7. And our first task is to find the complex impedance, which is shown here. We then look at the current in the circuit, right, which is the voltage divided by the impedance. Okay. And since this is an inductive circuit, we see that the current lags the voltage. We then find the complex power, which is the product of the RMS voltage times the complex conjugate of the RMS current. And we see that it, as expected, is complex. And that's illustrated in our diagram down here. So we have 68.4 watts of real power, and then 119 VAR. All right, so we'd like to come up with a compensating circuit that would eliminate the reactive power. We know that the reactive power is 119, and we know our input voltage, and we know that V squared over impedance is power. So our task is to figure out what is the requisite impedance, and this is what we see in our first equation here. From that, we see the impedance required by the capacitor. We can then calculate the capacitance from these two equations. And that is placed in parallel with our series resistive inductive load. And we now have a compensated circuit, as we see in our diagram down here. So all the power that's provided to the circuit is now dissipated by the 50 ohm load, which is exactly what we want. So we now have a power factor of 1.